Okay, so in this lesson we want to talk about higher roots, which means we're going to go beyond square roots to cube roots, fourth roots, etc. Okay, so we can start off talking about cube roots. I want to go through a table of the table of the cubes and the related cube roots. So if we cube 1 cubed is 1, which means the cube root of 1 is 1 because, because 1 times 1 times 1 is 1, of course. And the number that we can cube in order to get an answer of 1 is also 1. Okay, so 2 cubed, 8, right? That means the cube root of 8 is 2. Okay, so as you see to write the cube root, it's like a square root sign with a 3 off to the side. Okay, let's talk real quick the difference between that. That means the cube root versus something like that. That is 3 times the square root. Okay, this right over here in this part of the radical is called the index. Okay, so if you have a 3, it's a cube root. If you have a 4, it's a fourth root, etc. All right, so we have the next perfect cube, 3 cubed, which is 3 times 3 times 3, 27, which means cube root 27 is 3. Okay, 4 cubed, 64. So the cube root of 64 is 4. 5 cubed, 125. So cube root 125 equals 5. Let's talk about negatives. So if we cube negative 1, negative 1 times negative 1 times negative 1, remember odd exponents give you a negative, or just think about what's negative 1 times negative 1 times negative 1, that's negative 1, which means the cube root of negative 1 is negative 1. Now remember, for square roots, right, if we had square root in negative 1, that's just I, because there's no number that I can multiply itself by and get negative 1, because 1 times 1 is 1, negative 1 times negative 1 is also 1, all right? But with cube roots, you can have a cube root you can have the cube root of a negative that is a real number. Okay, let's look at another example. Negative 2 cubed, that's negative 8. Negative 2 times negative 2 times negative 2. So therefore, the cube root of negative 8 is negative 2. Okay, and we can go on and on this list. We'll do one more. Negative 3 cubed, negative 27. So therefore, the cube root of negative 27 is equal to negative 3. All right, same logic for fourth roots. 1 to the 4th power is equal to 1. So the fourth root of 1 is just 1. 2 to the 4th, 2 times 2 times 2 times 2, 16. So the fourth root of 16 is equal to 2. 3 to the 4th, 3 times 3 times 3 times 3, 81. So the next number on our fourth root list is the fourth root of 81, which is 3. Next one, 4 to the 4th. 4 times 4 is 16, times 4, 64, times 1 more 4 is 256. So the fourth root of 256 is equal to 4. One more for the positives, 5 to the 4th. 5 times 5 is 25, times 5 is 125, times another 5 is 625. So the cube root, sorry, the fourth root of 625 is equal to 5. Okay, let's talk about fourth roots of negative numbers. Well, if we raise a negative number to the fourth power, let's say I do -1 to the fourth power. It's going to be -1 times -1, +1 times -1 is -1, times one more -1 makes +1. Okay. But is the fourth root, well, let's hold off on that question. Let's see what happens when we do -2 to the fourth. Okay. -2 to the fourth, -2 times -2, -2, -2, so we've got 4, -8, 16. Okay. Notice when you raise a number to the fourth power, it always has to be positive, just like with your squares, like -9 squared, -9 times -9, positive 81. 9 squared is also 81, okay? So, moral of the story here, okay? So just like we had square root of -64, we know that's 8i, okay? The fourth root of -64, also imaginary. Okay, and we're not going to be really so concerned about what exactly the value is for imaginary numbers. We're going to keep it to square roots. All you have to know is that the answer is not a real number, as you'll see below. Okay, so evaluate the following, and again, tell if it's not a real number, just state that that's so. So we're looking for the fourth root of 16, and you get a negative in front, so we're just going to change the sign of it based on that negative. So the fourth root of 16 is right here on our list. So that's 2, and because we have a negative in front, we'll change the sign to -2. Okay, cube root of -27, right on our list, is -3. All right, fourth root of -81, well, we just said that the fourth root of negatives are imaginary numbers, so therefore not a real number. Cube root of -27, we just had that, -3. All right, nth roots with monomials. So here we're adding in a variable. All I'm going to do is I'm going to separate it apart like this. We're going to say this is equal to the fourth root of 625 times the fourth root of x to the 12th. All right, so from above, from our fourth power chart, we know the fourth root of 625 is 5. Now, to do the fourth root of 12, we need some power that when we multiply it by itself 4 times is going to give us 12. Let's say I guess it's x squared. That'd be x squared times x squared times x squared times x squared. Well, that, we know we add the exponents, that's x to the 8th, which is not what we want. Let's try x cubed. X cubed times x cubed times x cubed times x cubed, and yeah, we got 3, 3, 3, 3, which gives us 12. So the fourth root of x to the 12th is x to the 3rd, and of course we'll just write this as 5x cubed. Okay, cube root of 125 w to the 6th. I'm going to separate that as the cube root of 125 times cube root w to the 6th. We know the cube root of 125 is 5 because 5 cubed, or 5 times 5 times 5 is 125. So that's 5 times, and w to the 6th, the cube root of that, w squared times w squared times w squared will give you that w to the 6th. So that's 5 times w squared, which is 5w squared. All right, next thing we're going to do, we're going to use these nth roots to solve some equations. So as we've seen before, the inverse of a cube root is cubing, and the inverse of fourth root is fourth power, right? So number 4, we have this equation involving a fourth root. I'm just going to copy it down here. Okay, you want to start by isolating your root, just like we did when we were solving equations involving square roots. Subtract 3 from each side. So the fourth root of 7v plus 11 equals 3. Okay, so we said the inverse of the fourth root is the fourth power, so I'm going to raise both sides to the fourth power. Since fourth root and fourth power are inverses, they will cancel each other out. We have 7v plus 11 equals 3 to the 4th. 3 times 3 times 3 times 3, so we got 9, 27, 81. Okay, and of course we'll subtract 11 from each side. So we get 7v equals 70, and of course v equals 10. All right, the last one, cube root of 2x plus 2 plus 6 equals 8. Subtract 6 from each side. So cube root of 2x plus 2 equals 2. And now we know inverse of cube root is cubing. So we will cube both sides. Cube roots and cubes cancel each other out, so we have 2x plus 2 equals 2 cubed is 8. 2x equals 6, so of course x is 3.